Hello friends, today we'll be going to discuss about Dockers. So I'll be introducing the Dockers, what is Dockers, and this tutorial will be completely for beginners. So I'm going from the basic start of the Docker. So why we need a Docker? This is one of the mostly asked questions in interview or while starting with the Dockers. So in the previous, we were using one server, one VM virtual machines, and we used to install many operating system in that VM, and then we used to run many application in that VM. Okay, over here we will be creating a separate containers, and in the separate containers we will be running a separate applications. So there is no chances like one application may trouble another application. So that's the main use of Dockers. Earlier we used to use run one or more application on an VM server earlier version, but they may create some issues to the relative application. So there are chances of getting errors while running two or more applications. So IT landscape is changing. So mostly we are moving towards the cloud, okay, and DevOps opportunity like Jenkins and all, wherein you can create a pipeline, you can push your code towards the towards your Git, and it will automatically get renders in your Docker containers. So this is more of part of a Kubernetes that I won't be discussing in this tutorial. I'll be creating a separate tutorial for Kubernetes, then running an applications. And so this is just an example of how we are migrating toward the cloud. So next future is related to the cloud. So we are moving towards the cloud. All applications are moving towards the cloud. I hope you know what is cloud and different types of cloud services like software as a service, platform as a service, and infrastructure as a service. So basically, Docker is an platform as a service. Okay, wherein they will be giving you a platform to run an application. So these are the servers. Earlier we used to have a server, big servers, and then running a operating system on each servers. Okay, wherein nowadays modern application we are creating microservices such as breaking application into separate operations. So basically we'll be creating a separate service kind, and which will be handling the specific service like authentication of an user one service, then some image optimization one service, then such kind of many n number of services we will be writing. And this application will be whenever the user uses, and the application will be asking for this service, and then service will be handled. And only one application will be with number of services together. Okay, so continuous integration and deployment, which I told you earlier, we can use Jenkins and all. Yeah, wherein developers will be pushing his or her code in the Git, and then Git this Jenkins will be configured towards the containers, and then automatically this trigger will be running in Jenkins. It will be pushing, and it will be rolling out on the server. So basically it's a DevOps, like development and operations also. So DevOps, this Dockers and Kubernetes falls under DevOps categories, wherein we will be handling development as well as operations. So developers freedoms to create and deploy application, define and package application needs. So development will be considered in the developer sides, and then IT operations like publishing quickly and flexible response to the changes. New changes can be pushed towards the server, and then without a downtime also we can push it on the server. So there won't be any downtime towards the publication of the files. So this is very important when there is a need for the big application where then you can't afford a downtime on the application. That time this will be very helpful. So basically there are some tags in that, and wherein you will be putting tag version numbers to your service and your container or pods we say in the Kubernetes, and then you will be just targeting that tags with that pod or a container. Pod is basically a smallest unit in Kubernetes wherein pod will be containing your containers. That's a Kubernetes part that I won't be going in depth with that. So earlier one were the bare metals were there on premises, and then when Linux server was installed in that, and then traditional. Over here it will be a virtual cloud, Windows and microservices. I won't be going this. We'll go to the Dockers and container parts. Okay, this is the basic history of the Dockers, and then how it was got adapted in last 4 years. Be going much in this. There's another one of the physical servers wherein we have a operating system physical server and application running on that server. So limitation of the previous application development was is a slow and deployments time, huge cost, okay, wasted resources, difficult to scale. Yeah, scaling is one of the factors why we are moving towards the cloud. Uh, then even load balancing or those things which can be handled. That will be talking in the next slide, next videos. And difficult in migrations. Yeah, vendor. So virtualization, this is what we were talking about earlier. So we will be having a physical server, then host operating system. Host will be having his operating system, then hypervisor is the middleware, and then each VM will be having a guest operating system. This can be any Linux, Windows, any operating system. Okay. Benefits of using VM virtual machines: better resource pooling, easier to scale VMs in a cloud. Okay, these are the types: Amazon Azure Cloud Service and Amazon Web Service. Microsoft limitations requires each VM will be required the CPU allocation, storage, and RAM. Enter the guest operating system. So these resources are being wasted while using this virtual machines. So there where we come with the containers to solve this issue. Okay, then container Docker containers will be having a kernel, and containers for Tomcat. There will be more of repository for these containers in wherein you can check out a registry. It's called standardized packing for the software dependency isolations. Okay, and number of operating system you can get Ubuntu, SQL Server. These are the images which you can download. I'm just going with an overview of the applications. Okay, comparing containers with a VM infrastructure, host, operating system, Dockers, then application A, B, C, and which is having their own library. So over here you will be getting infrastructure, hypervisor, and then each will be having the guest OS. So over here OS OS requires lots of space. If you are going for Windows operating system, it will take around 1 GB at least. I'm showing minimum 1 GB. So 1 GB is being wasted. Okay, and it's heavy also to run the operating heavy operating system. It will require lots of resources. So these can be very useful containers will be. Key benefits of the Dockers very important: speed, no OS to boot applications. Okay, online in second, portable dependencies, And that's one point we mostly says in the dockers, like we should not have any attachment to the dockers containers, so wherein we can easily delete a containers and recreate docker files, docker containers. So we will be mostly focusing on the docker files, wherein we will be creating a docker files, and when running the docker files you will be automatically creating the image and will be start running with an application. So basically process, I'll tell you, you will be having a code on a GitHub. Suppose if you are having an application which you had pushed or committed to an GitHub. So what we will be doing, we will be creating one Docker file wherein we will be taking that image, whatever the code is there on your Git. So and then we will be downloading the required operating system and the programming languages. Like suppose if we are having a node application, then we will be installing some node.js packages and all those things, and we will be pulling those the code which is there on a GitHub, and it will automatically get configured using a docker file YAML. Okay, so in the YAML docker file we will be writing the code in such a way that it will be first installing all the required packages, and then it will be calling the GitHub, and then it will install all the other necessary requirement files such as package.json will be having all the files, those will be getting installed and it will start running. Okay, so if tomorrow your docker container is getting deleted, so then you just need to run that YAML file again, docker file again, and it will be running again on your server. Same thing, you can share it with your friends or your with your teammates, wherein they will be just running your docker files and it container will start running. So basic point what I want to say is that you should not have any attachment to your containers. Okay, then efficiencies of a container less OS head. So we are saving the space which is required for the operating system. In the previous which I had previous slide I had told you about this thing, like operating system in the VM virtual machines, we are installing our operating system which may take lots of GPs, and the resources also like RAM and storage and all those things which are we are saving in this docker container. So this is also a little bit important kind of Docker basics. Okay, image whatever I was talking, it's a basic of a Docker container. Okay, Docker hub is there wherein you can get it. Container, the image when it is running, the standard unit for app service. Okay, whenever the image is running, it is called as container. Engine, the software that execute the commands for the containers. Networking and volume are the part of an engine and can be clustered together. Registry, where registry is the outside thing which will be stored, distribute and manage Docker images. Okay, so there will be a public registry, there will be a private registry. Suppose if if you're working on your project in a company, then it will be a private registry. If you are working as a freelance or open source development developer, if you want to create your own registry and you want to share it with your friends or users worldwide, then you can create a new public registry and that can be used by others also. Okay, control panel, management of plan for the containers and cluster orchestration. Orchestration we will be discussing more in the Kubernetes. Cluster orchestration, we are going to use Kubernetes for this. There are Docker Swarm also, but I don't have that much knowledge about Docker Swarm. We are using Kubernetes. So Docker Foundation engine, security, integrated security, Docker engine, volumes, okay, storage. And next thing about Docker, one thing I want to tell, I just sharing with you. So we will be having a containers as well as we will be creating a volume for that. Network will be also the IP address will be assigned to that. Securities will be there. Security patches will be there. So while installing only you need to check the for that. So terminal microservice, containers build, environment ship and run. enterprise edition we want. Okay, building for secure supply chain. So we can have a private, as I talked earlier about a private image registry. Security orchestration, we are not talking about. Volume is for the storage. Okay, and then application and clusters management. And one more thing I want to tell you about this volume thing. Suppose if you are creating a containers and it is assigned with a volume, okay, and suppose tomorrow if your containers is getting deleted, okay, your volume won't be getting deleted. So we are keeping your data safe, because you can create a your clusters, sorry, containers, using just a Docker file. So tomorrow, if your Docker file is getting deleted, you are having the code on your GitHub, so wherein you can just pull that code and start running with your containers. But volume, where your data will be stored, so that we are not deleting if we are deleting any containers. Okay, that's a beauty about Dockers. That's it, guys, from my side about the Docker basics. Thank you for watching.